So normally the videos that I make about books have to do with books that I'm either going to read or use as a reference, but every now and then a collectible book comes along that is interesting, is historical, I find for a reasonable price, and I just get the book. Where did the idea for me to get this book by Ryser on combinatorial mathematics come from? Well, it came from Van Lint and Wilson, where they mentioned that the course for which Van Lint and Wilson was written is Math 121 at Caltech, that originally used to be taught by Ryser. Ryser. Let's call him Ryser. And so I said, it'd be interesting to have Ryser's book just to get an idea of how material evolves over time. In the case of Van Lint and Wilson, this is a book from, and I've already made a video about this book, that's why I'm not talking about it in detail. This book came out in 1992. And then in the case of Ryser, and this is what this video is really about, very small book, so I'm going to zoom in. And I'm not going to go back to Van Lint and Wilson in this video. Yeah, so it's a library book. It has a little bit of water damage that I'm totally fine with. The seller was like, "Hey, are you okay with it having some water damage?" That's fine. I mean, the book is usable. So it's from 1963. All right, so it's an old book. Now going on 60 years. Yeah, 60 something years, 62 years. And of course, you can stop it and read this. But this is basically an old combinatorics book. Of course, Caltech being a leading university, so yeah. So about the contents, the font is really tiny. Let me see if I can zoom in it a little more, because otherwise you're not going to be able to read it. Yeah, let's do it that way. We'll do like almost like half a page. So yeah, the fundamentals, the binomial coefficient, inclusion-exclusion, recurrence relations, Ramsey's theorem, distinct representatives, so matrices with zeros and ones, partitions. Oh, I'm sorry, and because I zoomed in, I did not, sorry about that. So I'm looking at the book and not looking at the video. I apologize for that. Yeah, so as I mentioned, yeah, inclusion-exclusion, recurrence relations, a theorem of Ramsey, and then distinct representatives. And then, and I'm going to try to get this right this time. Yeah, it all fits. Perfect. And I'm going to zoom it out when I'm done with this page. A focus on matrices of zeros and ones, Latin squares, which of course is where all this, it's all about KD tables and abstract algebra. Then combinatorial designs and perfect difference sets. So a very small subset of content compared to Van Lint and Wilson was taught in this class way back when in the 60s. Yeah. The notation looks readable. The book looks readable. Of course, it's a tiny book. It's got theorems, corollaries, examples. Nicely written proofs. Yeah, I'm not sure I would consider it a reference because of how brief it is, but maybe for some obscure topic when I get around to doing combinatorics, it'll be good to come back to. References of other books. Inclusion-exclusion is used in the sieve of Eratosthenes in number theory. I remember that from Rosen's number theory book. Recurrence relations. Menage numbers. Never heard of that. Ramsey's theorem. given integers satisfy this inequality, then there exists a minimal positive integer with the property that the following proposition is valid for all integers. Yeah, I'll have to study it to do it justice. I'm just reading it like an ignorant person that I am in the case of this book. Yeah, so I don't need to show the whole book, just giving you an idea of what it looks like. If you want to collect it, maybe use it as a reference. Not sure if I plan to use it as a reference. I just got it more as a curiosity because occasionally, when I get around to Van Linta and Wilson, I'll be curious about how Ryser would have discussed the same topic.